Okay, so your vacations are going right now.
Yes.
All right. So before the vacation, this much has been
Yeah.
completed. All right. Now, class, in the last class, we had done the series and parallel combination of registers. We have completed that. So today I'll send you the students who have not attended that capacitor, but now you'll be able to understand series and parallel combination of capacitors. So today in today's class, we'll do Kirchoff's law. So it's a short class today. As you people also know, you have your test today. So Kirchoff's law in you have to understand few things in Kirchoff's law. Otherwise, this understanding portion of Kirchoff's law, it's just totally based upon the questions. Without the questions, you won't be able to solve this. So first, let us understand the basic rules. Few things I have written prior to the class, that is the Kirchoff's first law and Kirchoff's second law. Kirchhoff's first law is very, very easy. All of you can understand it. Yes, if you have any doubts from the previous class, series and parallel combination, anything, you people can ask me right now. So you can text me. Meanwhile, I can read your doubt. Now, Kirchhoff's two laws are there. First law is related to current. Second law is related to voltage. So Kirchhoff's first law basically says that whatever is the amount of current now that is entering a point or a junction, you can say. Junction is basically the crossage of wires where the wires cross each other. What test? What is the topic? I hope I've shared with you people on the group, no? Drift velocity and Ohm's law? Yes or no?
You did.
I did, no? Yes. Abhi, you're not added on the group or what? You are added.
No, ma'am, I'm not on the group.
You're not on the group. All right, I've asked them to add you also. And one or two students were there also in the other batch. Fine, Abhi, it's okay. So if you just see the question paper, take the question paper. If you are able to do it, you can, because it's a recent topic. Current electricity is initial portion only. Drift velocity and Ohm's law. So Ohm's law is V is equal to IR, that only. If you think you see the level of questions, you think you'll be able to do it, then you attempt the test. Otherwise, take the screenshot of the paper and you can do it later, because as you were not aware. All right. I'll ensure again about the group thing. I didn't know that you were not added. Otherwise, I would have sent you the message. This message I gave, I think, on Saturday. I remember the announcement for the tests. And now your tests will be conducted more frequently, because now so many derivations are getting as soon. See, this is class we have on Kirchhoff's law. The next class we'll be ending this lesson. And from the next class only, most probably we'll be starting with magnetics. So there will be lots and lots of formulas and lots of derivation. So for that matter, you have to start revising everything, and that's why we have these little subjective tests in the class. Till now we have had just, I think, 2 or 3 tests with you people with this batch. All right, so Abhi, it's up to you. Same thing goes for Amrita. Same thing goes for you. You analyze the question paper. If you think you're able to do it, just attempt it, because this is just a class test. These marks, not they won't be added in your board examination. So even if it is slow, nothing, it doesn't matter. All right, so if you think, that goes same for Amrita and Abhi, both of you. If you think you're not able to attend the paper, you won't be, so it's okay. You can take the screenshot and do it as an assignment later on, but do it. The rest of the students should be there. Reem, you won't leave today. Fahad, Reem, Rifat, Samia, Wafia, and Zaid. You should attend the test. It's a very easy test. I'm telling you, very easy test I've conducted. You will all be able to do it. The similar test was conducted in other batch. Maximum students scored very good score. You will also be able to do it. Now, Kirchhoff's law, coming back to the topic. Kirchhoff has 2 laws. First law deals with current, second law deals with voltage. So first law basically says that whatever is the amount of current that is entering a junction. Junction means crossage of 2 wires. Like if I say this is one wire, this way, this is another wire. So this is a junction. This we call as a junction. So current entering a junction will be equal to current leaving a junction. We call this as a junction. Wires made up of it can be a continuous wire, it can be wire made up of breakages. Now whatever current will be entering the junction, that amount of current will be exiting from the junction. So net current, if you calculate, that will be zero. Algebraic sum of all the currents at a point, at a junction, becomes zero. And this property will be helpful for your further solving of your questions. Questions you all will be able to solve it. It's just that you should know how to solve, means the basic sign conventions. Otherwise, Kirchoff's law, directly we'll do the questions today. Today only we'll see the questions. Now, so similar here, if we see it, just see I1 is entering the junction, I4 is leaving the junction. So whatever things are entering the junction, let's say they are positive. So net current will be what? I1, let's say it's positive because it is entering the junction. I4 is what? I4 is leaving the junction. So this is minus I4. I3 is also leaving the junction, so that becomes minus I3. I2 is entering the junction, so we call it as plus I2. Sign convention, we have chosen that all the current that is entering the junction is equal to all the currents that are leaving the junction. So this is equal to 0. This is just your Kirchoff's first law. This is just your Kirchoff's first law. Whatever you see, current entering and leaving, put the sign accordingly, equate it to 0, your work is done. Now, if you have to further solve it, you can see I1 plus I2 will be equal to I3 plus I4. It's just that I have transported everything to the right hand side. Now, second law, this is also known as Kirchoff's current law. One thing, you can write it down later. I'll give you sufficient time. So don't write down now. I'll give you time. Kirchoff's second law basically says that it is known as loop law, or this is sometimes called wire mesh law also. Loop law, remember loop law. Kirchoff's voltage law, KVL. So this is the Kirchoff's second law. Now, Kirchoff's second law is used in combination with Kirchoff's first law to solve questions, because many times what happens, your resistors are connected in such a way that you're not able to either identify them either as series or parallel. You'll get confused at a point of whether this combination is connected in series or the combination of resistors are connected in parallel. So in that case, if you apply Kirchoff's law is a full proof concept which will definitely lead you towards the answer. That is the advantage of Kirchoff's law. Disadvantage of Kirchoff's law is that it is very lengthy. It is very lengthy. So wherever you are able to identify series and parallel, it's a big advice that escape Kirchoff's law. If you are not able to identify series, parallel combination and all these things, then definitely go for Kirchoff's law. You will get an answer. So advantage, disadvantage, I have kept it in front of you. Now, Kirchoff's voltage law says net potential will be 0, and this is what we will be doing. Firstly, we'll apply Kirchoff's current law. We'll spread the current in whichever direction it is going, and then we'll be applying Kirchoff's voltage law. This is the main law. Wherever we are getting the net voltages, we'll take out the sum of all the voltage, equate it to 0. This is the Kirchoff's second law. So it says this is loop law. Around any closed loop of a network, the algebraic sum of changes in potential is 0. That is, sum of all the potentials are 0. This is what is known as Kirchoff's voltage law. Now, sign conventions, few sign conventions you have to remember right now only. Other sign conventions, as the questions will go and as the time will pass, I will let you know. If your current has begun or is beginning from the positive terminal of the battery and is terminating towards the negative terminal as shown in this figure. Starting from the positive terminal, ending towards the negative terminal. Your potential will always be positive no matter what. V will be positive. If it is given 5 volt, write it as 5 volt in your equation. If it is given as 100 volt, write it as 100 volt. If vice versa happens, that is from negative polarity, the current begins its journey and it terminates in the positive plate of the cell. Always and always write it as negative. Your current, your voltage value in the question has been provided as 5 volts. While using the sign convention, if you see this is the second case, you will write it as -5. You will not see what the sign the question has provided you. You will see the signs according to you, whichever the signs are. If you see such a case, put it as positive. If you see such a case, directly put it as negative, without any information, without any other information given. This is the first thing that you have to remember. Now, if you move along the direction of current, let's say this is a resistor, must be having value of resistance R. Current I is flowing. So this is the positive side, this is the negative side. Current I is flowing. In the questions when we will be solving, no, right now only I'll show you. We take a direction. We take a certain direction of motion of our movement. How will we be writing all the values of potential? A direction means supposedly a circuit has been connected. Let's say a circuit has been connected. Here is one more. Here the key has been connected. Either we move in this manner or we can move in this manner. So this is the motion that I'm telling you, not any other motion of charge. All right. So in the motion, while you're performing or while you're going through it, no, if we are going in this way, means along the direction of current. This you may not understand right now. Don't worry. At least these 2 points you can hold it. With the question, you will be able to understand. And for all those who are able to understand, very well. So along direction of current, you take the value of it, means I into R, that is your potential, as positive. This will be negative if you are moving along the direction of current. If we are moving in this way, opposite to direction of current, then you write it as positive. Now with this sign convention, you will be able to solve all the questions. We'll begin with questions. We'll do certain questions, but before that, note down these points and at least first law and second law, be clear with it. I hope you people are revising the first and second lesson, because third lesson is also almost at the end. You people are having doubts, you have to ask. Otherwise, the doubts will get piled up and you won't be able to understand. Many students from Learnivio this time in 12th standard that scored excellent scores, especially from that Bahrain batch we had. I think Fazil Mohammed scored 96.4%. Abdullah Aslam scored 94.2%. Noor Alok also has scored a very good percentage. These students were there in the last batches. So what did they used to do? They used to ask whatever their doubts they had. Either they sent me on the WhatsApp, the doubts got cleared on the WhatsApp itself, or if sometimes they have lots of doubts and it wasn't easy for them to get it solved on WhatsApp and they were not able to understand. So separate class was arranged and even revision classes were there for them. So now you people have a separate group, so you can even send your doubts and anything on the group as well. Or if you're hesitating to send the doubts on the group, you can send me personally. You all have my number on the WhatsApp group. The number is connected. So whatever doubts you people are having, ask me. Just go through all the derivations soon. In the next week, most probably next Thursday. Around next Thursday, we will be having one more test, but that will include all the derivations part only. Because I want to check whether you people are performing derivations correctly or not. Because derivations are very scoring. That we'll discuss on Thursday for the next Thursday. Done the writing part. That's yeah. All right. Others are also written. I think all of you have written, no? Yes. All right. Okay. Now I'm giving you a question. We'll do that question together only. But in that question, just understand everything, how to solve it. We'll do more questions. But be careful while we are discussing this question. And one more thing, this is a question from your NCERT only. So don't think that this is some tough or extra question that we are discussing. Yes, obviously this can be lengthy, that you will see yourself. So a cell has been connected. So a cell has been connected here and one more register is this way. Let's name this point A, this point is B. In this question, yes, Fahad, you will see. I'll tell you how to use first and second one. I'll tell you. This is B, this is C point, this is D point. This is given 4 ohm, this is given also 4 ohm, this is given 10 ohm. Yes, this is given 10 ohm. No, this is given as 1 ohm. One resistor is also there. One battery is there, which is 10 volt. One resistor is there, which is 10 ohm. This is 2 ohm. This is 2 ohm. Another one is 5 volt. This is 5 volt. This is the question given to you. You have to find the correction, current, resistors, everything. But first step, application of Kirchoff's current law. Current law, what did we see? In the current law, we had seen all the currents entering the junction is equal to current leaving the junction. So here right now you have to decide the direction of current. See, at the end, it can be confusing if you directly try to look at the figure and understand, because many things are written in the figure, many things are drawn on the figure. It can be confusing. So best solution for that is, whatever I'm teaching you right now, see along with me only. Try to learn it along with me. Don't leave your place and go somewhere for even 2 minutes. Just understand this carefully, you will be able to do. Because this is just understanding. No formula can be given to you, nothing can be given to you for this. Now, let's say from this battery, I1 current has started. All right, let's say I1 current has started from this battery. So if I2 current, this is up to you, totally up to you. From here also you can start. I saw this battery, so I started from here only. If you see this battery, you can start from here. How your and my answer will be different. Let's take example Z. Z has started from here and he has named this current as I1. I have done the same question and I have named this current as I3. I1 done, I2 done, I3. So you people will say your current's value I1 is different, Z's value is different. Thing is that for me, which current is I3? For Z, it is I1. But in the branch, in this B branch with this battery, both the value of currents will be same or not. The value that Z will be getting on solving and the value that I'll be getting on solving will be the same. So for me, what's I3 will be the same thing that will be for Z in terms of I1. So this is how your answers will differ. It's just that the examiner will see the things in such a manner Examiner will see the things in your way only. Whatever you have written, whichever sign convention you have chosen, the examiner will write in that only. So even don't even get confused that I have started from this battery. You can start from any battery, you can start any wish, you can take any variable. Kirchoff's law gives you free hand, a lot of liberty in solving questions. So I've started from here and try to choose minimum variables possible. For example, I could choose I3 for this wire, but what I'm seeing, if I1 current is flowing, I2 has gone, so I minus I2 is left. So instead of taking this as some other current, let me take it as I1 minus I2. The current flowing through this branch is I1 minus I2. Current coming to this branch, this is what? This is I2. I2 came to this B point. Fine. All right. So I2 came to this B point. Let's say I3 also came. So if I2 is coming from this branch, I3 is coming from this branch, can anyone answer what will be the amount of current that will be flowing downwards now? I2 is coming from this, I3 is coming from this. So total current that will be going through BC?
Doubled.
Not doubled, added. I2 plus I3. Did you get it? All of you? Abia? In this wire, I2 plus I3 will go till a junction. I3 plus I2. Yes, yes, yes. Okay. I2 plus I3. Now at this junction, what was the current flowing in this branch? Obviously, if I1 is there, I1 current will be here also. So I1 has gone. I2 plus I3, I1 has gone into this branch. Because obviously I1 we had taken, so in this branch it is I1 only. So if I1 has gone, this becomes what? I2 plus I3 minus I1. Did you get it? No? Yes or no? Any doubts in here? See, now this was I3. In this wire, it was I3. And you can even check it from here. If you add these currents, no, I1, I2 gets cancelled, only I3 is there. So that also proves you. See, I1 minus I2 coming from here, and plus I2 plus I3 minus I1 coming from here. I1 got cancelled, I2 got cancelled, only I3 was left, which was fine. So this shows that now the current that I have chosen, I have completed all the wires. First, tell me, this is the first step. Any doubts in here? Yes, no, at least respond. How will I get to know? Have you people understood or not? How we get I1 minus I2? I1 minus I2. Here, see there, I1 current I had started. I had to name another variable, so I took that second current as I2. Now, if I1 was coming, I2 has gone. So how much will be left? 5 ampere was coming, 3 ampere has gone upwards. So how much amperes will go downwards? 2 amperes. 5 minus 3, I1 minus I2. Got it, Zaid? And other students, clear to all of you. Good. So this step you have understood. Now it's very easy. It's very easy. Just start going along with me as I go. Clear? We'll do more questions. It will get clear. Don't worry about it. But go along with me. Fine? In the loops, you can take any direction you wish to. How I2 plus I3 minus I1? See, in this branch, we had started with this branch. So I had taken I1 current is coming out. Whatever current that's actually a good question, Fahad. Whatever you take the current in a single branch, that complete branch has the same current. Remember, what did we do when we were discussing series and parallel combination? That if the wire remains the same and branching doesn't occur, then the current's value remains the same. So this was a single branch. If I1 was current that was coming out out of 10 volts battery, then obviously I1 would have been there in this wire only. As soon as we saw branching came at this junction C, at the junction A, at the junction B, at the junction D, we saw current got divided into paths. So the application, whatever you studied those earlier in series and parallel combination of capacitors and everything, you are able to see it in the same order. Fine, everything is getting repeated only. It's just that the solving part is different. So I2 plus I3 was coming, I1 has gone. So again, it's the same thing that Zed asked. If I2 plus I3 is coming, let's say 5 plus 3 is coming, 1 has gone. So will 5 plus 3 will come still? 5 plus 3 minus 1 will come, no? So the way we have taken in terms of variable. Clear? Now the application part. See, we have to choose any loop. Loop means any closed circuit. See, if you see, you are able to see 3 triangular loops. One is this complete closed loop, ABC. One is this loop, one is this loop. So you have 3 loops. You have 3 variables. You can generate 3 equations by yourself. See, how will we do? Let's take ABCA loop. ABCA. Why am I writing ABCA and not ABC? Because it's a complete complete loop. It's a whole complete loop. If I only stop at point C, then it becomes open. But this is a closed loop. So I have to write, when I write point A back, no, it shows that the loop is closed. You can take any direction, clockwise or anti-clockwise, any direction in any loop. Let's say this is, we have taken, this is which direction? Clockwise. Let's take it randomly. That's why I'm saying Kirchoff's law gives you the liberty to solve it anyway. It's just that it's very lengthy, very lengthy. 3 equations, 3 variables. That definitely eats our brain while solving. But since these kinds of questions, as you can see, these cannot be solved without help of Kirchoff's law. Now let's start the motion. We are moving clockwise. So we are moving like this. This will be our motion, clockwise. All right, see my fingers tracing path and see the direction of current that is flowing, like this. So let's start from A point. We are moving along the direction of current. What did I tell you? When you're moving along the direction of current, then your current becomes negative, voltage becomes negative. I2 is the current, resistance is 4, V is equal to IR. Don't forget this Ohm's law. Current into resistance. So we'll write minus I2 into 4. Or I think it's better if I write it as minus 4I2. This is voltage, this is resistance multiplied by current. That gave me the voltage across this. And regarding the sign, it will be negative because we are moving along the direction of current. At B point, this is B point. At B point, I have stopped. Now we are moving downwards. We are moving towards the direction of current, or along the direction current or opposite of the direction of current. Along the direction of current. So this will also be negative. So current in this branch is what? Along. Yes, we are moving along. So rightly answered Z. It is we are moving along. So this will be negative. Current into resistance. Current is I2 plus I3. Resistance is 2. We have solved this also. Now let's move from C2 towards A. We see this. We are moving again along the direction of current. So we'll write it as minus I1 into 1. That will give me I1 only. And then from the positive terminal, it's getting generated, entering the negative one. What did I tell you? If it's this case, then we have to write it as positive. So this becomes plus 10 equal to 0. Got it? Yes, no, any doubts? I'll explain you again. Should I explain again? Or it's better if we do other loops, then I think you'll be able to understand. Just wait, let's do other loops. Let's just take this loop and let's now move anti-clockwise so that you see we have the liberty. So which I'm taking A, D, C, D. A, D, no, A, D, C, D, no. A, D, C, D, A. A, D, C, D, A. Now, from A to D I am moving. Try to unmute yourself and answer, all of you, so that I will know whether you are able to actually understand or not. Try to unmute and answer as soon as I, because this is just based on the questions only. If I am moving from A to D, am I moving along the direction of current or opposite? By minus 4I2. Samya, see. See, Samya, otherwise it won't get clear. It's good that you've asked. See, Samya. Resistance is 4 ohm. Current through this branch is I2. What will be the voltage? Just tell me the voltage, Samya. Voltage. V using V is equal to IR. What will be the voltage value? Samya? Samya, current is I2, resistance is 4, voltage will be V is equal to IR. What should be the voltage? Are you here, Samya? Yes or no? Okay, 4I2. All right. Yes, it will be 4I2. Definitely, this will be 4I2. Now, look at the figure. 4I2. Now tell me, Samya, when we are moving clockwise, you can look at this. Just wait. See this. We are moving clockwise. So clockwise means what? Clockwise means this direction. This is the direction we are considering. This is the direction we are considering. This is clockwise. Had we taken anti-clockwise, we would have been moving like this. Are you able to see? Like this, we have to move clockwise. This is the direction that we have chosen. Tell me, when I'm moving from A to B, am I moving along with the direction of current or opposite to that of current? Along. Whenever your direction is along, put a negative sign. Clear now, Samya, how we have got minus 4I2? Students, try to unmute yourself and answer, because it takes a lot of time. You type, then I read the answer sometimes reach later on. So it's better for all those who can unmute themselves. So definitely that's better. See, even your cameras are not open. Many students use their mobile phones while typing. In a class only that occurred in your 12th batches only. One of the students, by mistake, his camera got open. And he was constantly using his mobile phone, and everybody in the batch was seeing. So you people do that. So at least it's better if you unmute yourself. If you're not able to, any problem is their mic is not working, people are there around you, then it's fine. Otherwise, try. Now let's move through this. So Fahad answered, I think. He said we were moving ADCA. Yes, ADCA was the loop. Tell me, in this branch, if I am moving anti-clockwise, this is the direction. So from A to D, am I moving along or opposite? Opposite or along?
Hello.
Along. See, it will be along only. Opposite would have been this Z. Right now, I'm not considering clockwise. I am considering anti-clockwise. Anti-clockwise means this, opposite to the motion of clock. So we are moving along. It means minus sign will definitely come. Current into resistance. Resistance is 4. Current is I1 minus I2. This we have solved. Now all of you tell me, from moving D to C, are we moving along or opposite?
Opposite.
Opposite. Perfect read. We are moving opposite. So this is what I was meaning. Yes, Sami, it will be opposite. So this was what I was telling you, motion opposite. Now we'll add a positive sign. Resistance is 2. Current is I2 plus I3 minus I1. See, this branch is also solved. Now this branch is similar to what we have studied. So this is again becoming, we are moving C to A. So along or opposite? C to A.
Along.
Yes, along.
Along.
Correct. Perfect. So all of you are responding. That's good. We are moving along. So it will be again a negative sign. Current multiplied by resistance is 1. So I'm not writing 1. Again, this is from negative terminal to positive terminal. You put it as positive. This is equal to 0. Second loop also we have solved it. Take the third loop. Any direction you wish to take. Which direction? Let's take again clockwise. This time we took anti-clockwise. Let's take clockwise again. This loop is BCDB because this is actually in this way, no? So the loop will be BCDB loop. In loop BCDB, let's start writing. All right, in this loop. So from B point to C point, I am moving. From this B point to C point, I am moving. Am I moving along or opposite?
Along.
Along the direction. Yes, yes, Wafia Fahad, right. We are moving along the direction of current. So it becomes negative. Resistance is 2 ohm. Current through this is I2 plus I3. This has been solved. All of you now write me in the chat box what should be the value of voltage that I should take for C to D. Minus whatever value plus whatever value according to you. C to D. Everyone should write me in the chat box right now. Yes, class, from C to D. Negative, yes, Amrita, it will be negative minus 2, I2 plus I3 minus I1Z, I think, and that must be your typing error, no? I1, you must be writing. Fahad, correct. Minus I2, minus 2 into I3, plus I think that again, Wafia, that would have been 2. By mistake, I think you must have written I3 minus I1. Reem minus 2, I2 plus I3 minus I1, perfect. Rifat minus 2, Rifat, along with I2 plus I3, no, we have minus I1 as well. So what you have written, that's correct. All of your rights. Minus 2, Rifat, just one thing that was missing in your answers. The total current is not only just I2 plus I3. We have minus I1 as well. Fine. Now the last thing, this is very easy. We are moving from here to here, means from the negative to positive terminal. This will be plus 5 volt. This will be equal to 0. So obviously we won't be solving all these questions in the class right now. That will just be simply waste of time for all of us. You have to solve these questions after the class gets over. 3 equations are there, 3 variables are there. You will be able to easily get the answer. But this is how to apply Kirchoff's law. Note it down. And anyone who writes it fast or writes it quickly can find the value of I1, I2, I3 as well. And any doubts in any part, ask me. Fahad, any doubt?
Ma'am, we are just adding voltage. We are not adding I3.
No, we are just adding voltage. See, using the current Kirchoff's first law, that was the current law, we distributed all the currents. Whatever current entered the junction left the junction. Remember? See, we did this, no? This calculation we did. How to find out. So first law has been utilized in setting the current. Secondly, we are actually writing what? Net potential, that is equal to 0. That's why I was telling you that second law gets used a lot more than the first law. First law you have to set. Adjust by adjusting. Second law, constantly you have to use the voltage. Fine, Fahad?
Yes, ma'am.
Just text done in the chat box, so I'll know. And if you still have any queries, if you have any doubts in this, any part, any portion, text me the doubt. You can even write if you're hesitating to ask in front of everyone, so you can even text me in the chat box. Okay, Fahad is done. Others also let me know. Don't worry about the test. Test paper is very easy. Drift velocity, because you have done it recently. Okay, Amrita, Zaid, all of you have done, no? So let me start with the test. Abia, Amrita, up to you. Others, please give the test. And I'm still saying, for students who are having difficulties, who are facing issues in any of the topic, in any of the questions. See, if you're having no doubt in any of the question, it means you people are not practicing. If you practice, it can obviously be happening that you will get doubts. You can ask me on WhatsApp, even you can ask. If it's very urgent, you have your exams, you can even call me. So fine, your test has begun 2 minutes earlier only. For me, it's around 9:58. So at 10:30 means half an hour duration. Fine, Abhya, but at least have the question paper with you. If you take the screenshot, or if you want me to send the PDF, I think it's better if you take the screenshot with you. So it's okay if you're not able to. You have taken it. Fine, Abhya. You can leave. What about you, Amrita?
So I have taken screenshot.
Yes, can you repeat?
So I have taken the screenshot.
All right. Fine, Amrita. You can also leave. Otherwise, we have the classes till half an hour more. So right now I'm stopping the class because we had the test today. Otherwise, are you added on the group? No, you must also not be added. I'll inform about you. I'll add you on the group. You can also leave, Amrita. The next class, you can continue.
Okay.
Yes. For the second question, resistance is 1 kilo ohm. You have to convert it into ohms. Otherwise, you won't get the answer. And apply the quantization of charge. That will help you in the second part. First part, you people must have done by now. That was very easy. Second, third is the derivation. Derivation, please do it properly the way you have to appear it from in your board exams. Whatever mistakes you will do, that I'll tell you.